Do you know how Google Lens identifies the object that is being shown on photos and it is suggesting you products? Or how weather apps predict tomorrow's temperature? That is the magic of machine learning or ML for short. It is a branch of artificial intelligence that allows computers to learn from data instead of being directly programmed. Today, we will deep dive into three major pillars of machine learning: regression, classification, and clustering. By the end of this video, you'll know exactly how they work, what kind of data they use, and when to use each one, even if you are just starting out. Let's start from the basics. Imagine you are teaching a kid to recognize apples or oranges. You show them pictures and tell them this is apple, this is orange. After seeing hundreds of examples, the kid starts identifying them correctly, even new ones they haven't seen before. That's exactly what machine learning does. You feed the machine data and it learns patterns from that data to make predictions or decisions. But when it comes to machine learning, it is not that hundreds of examples. It's more than that because machine learning has the capacity to learn and understand patterns very clearly only if you feed enough amount of data. So in this scenario or in this case, it needs at least thousands of images of apples and oranges to identify which is apple and which is orange. So that is how exactly machine learning works. As a human being, we see through eyes, we decide through brain, and we give output through our mouth. We say what it is. As similar to that, machine learning has three main steps to make a decision. The first step is data collection, gathering examples or observations. That is a step where it collects data. As a second step, model training. The model learns patterns from this data. It might be an orange or it might be an apple based on how it looks, how the structure is, how the color is. As a third step, we do have prediction or inference. It uses what it learned to make decisions on new and unseen data. There are different types of learning depending on how data is provided to a machine learning model. The first type is supervised learning. Here you provide data with correct answers. The second type is unsupervised learning. Here the machine finds patterns by itself. As a teenager, how they have the ability. As a third type, we have reinforcement learning. Here, it learns through rewards, as similar to how every human beings love gifts and they hate penalties. This reinforcement learning does the same. So, in this video, regression and classification fall under supervised learning, and clustering falls under unsupervised learning. Let's break them down one by one. First, let's try to understand what is regression. You have a goal of predicting the price of a house based on its area, location, and number of rooms. You might want to predict the price of a house if you want to buy a house or if you want to sell a house. In this case, the output is the house price, which is a number. That is where regression comes in. That is how machine learning is used in this process. So, regression algorithms predict continuous numerical values. The goal is to find a relationship between input variables, features, and an output variable target. Let's take an example. Suppose you have data like this, which has columns like area, bedrooms, and price. Let me give you 5 seconds. Try to guess which are features and which column is a target. Time starts now. I believe most of you guessed it right. Yes, the target column is price, and the rest of the columns are called as features because it is used for predicting a target column. Regression will try to fit a line or curve that best represents the relationship between these inputs and outputs. This line helps us predict values that are new. This process is called as model fitting. The simplest type in this is linear regression because it draws a straight line. Here, the features are directly related to the target column. Whenever the values in the features get increased, the values in the target column will also get increased. But when the data has complex patterns, we use other models like polynomial regression for curved patterns, rich and lasso regression to prevent overfitting, or decision tree regression, or random forest regression for more complex and nonlinear data. These regression algorithms can be used for predicting house prices, stock price forecasting, temperature prediction, estimating sales or revenue of a company. Now let's move to classification. Instead of predicting numbers, classification predicts labels or categories. Is this email a spam or not a spam? Will the patient test positive or negative? Is this image a cat or a dog? Here, the machine learns from label data, data where the correct category is already known. Let's say you have this data, which has columns like hours studied, sleep hours, pass or fail. The algorithm learns patterns that separate the two categories, pass or fail. So next time you give new inputs, it predicts which side it falls on. The boundary that separates classes is called a decision boundary. Some famous classification algorithms are logistic regression, decision trees, random forest, support vector missions, naive Bayes, and k nearest neighbors. Here, logistic regression, despite the name, it is used for classification. These classification algorithms are used for email spam detection to detect if it is a spam or a not spam, for sentiment analysis in analyzing if the review is positive or negative, in fraud detection, in disease diagnosis, in image recognition, cat or dog, human or object. In short, if your output is a label or category, you are doing classification. Now let's talk about clustering, which is a completely different kind of learning. Unlike regression and classification, here we don't give the model the answers. The machine has to discover hidden patterns or group similar data points together all by itself. Let's imagine you own a shopping website and you have data about thousands of customers, their age, income, and shopping habits. You want to divide them into groups, maybe budget shoppers, luxury buyers, and occasional visitors. But you don't have labels for them. That is where clustering helps. The algorithm automatically finds clusters, groups of customers that behave similarly. The most common algorithm is K means clustering. It works like this. You decide the number of clusters, say 3. It randomly assigns cluster center. Then it repeatedly adjusts those centers until the clusters become stable. Other clustering methods include hierarchical clustering, DB scan, density based spatial clustering, Gaussian mixture models, GMM. These clustering algorithms are used for customer segmentation, market research, image compression, social network analysis, document grouping. So, if your data has no labels and you just want to find patterns or groups, go for clustering. When should I choose which algorithm? If your goal is to predict a continuous value and you know very clearly the output is definitely going to be a number, then you should use regression algorithms. Use them wisely based on the values and based on the scenarios. Choose the type of regression algorithm. If your goal is to predict a category and that output has a clearly defined label, then choose any of the classification algorithms. If your goal is to find hidden groups and the output is that particular output belongs to a particular group and the algorithm need to find the hidden patterns, then go for clustering. That simple it is. So, machine learning is about understanding your data and your goal. If your goal is to predict numbers, think regression. If your goal is to classify into categories, think classification. If your goal is to discover patterns, think clustering. That is the foundation of every machine learning project. And once you understand these three, you can go much deeper into AI. If you found this helpful, don't forget to like the video, subscribe, and comment below what topic you want next. Until then, keep learning, keep building.